So that's cool, but all of these just show that there's some special part of the brain and or mind that does face recognition that's distinct from parts of the brain or mind that do other kinds of visual processing. Really, we want to go beyond that. We want to ask what exactly, okay, so these things exist. We want to know what information is represented in each of these regions. Okay, what do they do with faces? Not just that they respond a lot with faces and mess up your percept of a face. What do they represent about faces? Okay, okay, so I'm going to describe 3 different methods that you can use to try to characterize what a region is doing beyond just saying what it's specific for. Okay, one is just a simple measure of differential response to different stimuli. Okay, and another is a method called functional MRI adaptation that I'll explain. And another we've talked about briefly, but I'm going to talk about it some more, and then Mike is going to talk about it some more, and that's multiple voxel pattern analysis. Okay, okay. So first, for simple measurements of differential response, I'm going to skip through this briefly because you guys have already watched an experiment being run on these very stimuli. These are our faces, scenes, and bodies and objects that you saw that we scanned me on in the first class. And so when we first ran this experiment, we found that we got very strong responses to faces in that superior temporal sulcus region. All the other regions we scanned were, okay, the fusiform face area looks fine, occipital face area looks fine, but the response in that superior temporal sulcus was bigger than what I'd seen before. In fact, I haven't published very many papers on that region because I can't usually find it. It's kind of wimpy and lousy. But with this method, that superior temporal sulcus face region was really robust. So then we thought, why is it speaking up so strongly with these movies? Does it really require motion? Okay, so David Pitcher, who was then in my lab, having just come over to learn functional MRI, the TMS whiz, said, okay, let's look at that seriously. So we took our 3-second movie clips, like the ones you saw me be scanned on, and we just took each one and broke them into 3 1-second stills like this. So here's a 3-second movie, and we've just extracted 3 stills through here where each of these is on for a second. Okay, so that's not very different from the continuous movie over these 3 seconds. These are, from the same order. You can almost infer the trajectory, but they're 3 snapshots instead of a movie. Okay, so we ran that localizer you saw, very same localizer, in these 2 ways: the movie version and the snapshot version. Okay, block design, everything else is the same. Okay, okay. Here's what we find. This is the right fusiform face area and its magnitude of response. So as usual, you identify that region with other data not considered here. You identify it as a higher response to faces and objects, and then you measure its response to these conditions. And you see there's a higher response to faces and bodies, scenes, objects, and scrambled stimuli as expected. It is a fusiform face area. After all, that's what it's supposed to do. That's what it did. More importantly, the black bars are the movies, and the white bars are the stills. And you can see that the fusiform face area does not give a damn about whether it's looking at movies or stills. Okay? It just gives you exactly the same response. It doesn't care. Okay, similarly, the occipital face area, that little thing out on the lateral surface toward the back of the head that you can zap with TMS right out here, is pretty similar to the fusiform face area. It's a little less selective than the FFA, but it's pretty similar, and it also does not care about whether it's looking at movies or stills. Yeah? But the superior temporal sulcus region is also selective, but cares deeply whether it's looking at, sorry, you can't see that, whether it's looking at movies or stills, right there. Okay? Response is about 3 times as high to face movies as to those 3 1-second stills from the very same movies. Okay? So we don't know why that is, but I think the entire hypothesis space of all the things it might be, all of those things are interesting. Okay, so we haven't nailed which of them is right, but I think it's very, very important and interesting. So this is something we just sort of stumbled into. It's a pretty simple experiment. It's a block design. Just measure the magnitude to a bunch of different kinds of stimuli. It's sort of the simplest thing you can do with functional MRI, and yet it's revealed a dissociation. Like, who knew that that region was so fundamentally different than the other 2? Okay? So it doesn't take us that far. It doesn't tell us what it's doing, but it's giving us an important clue.